Good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching Hacking Raspberry Pi series, a zero to hero series. Alright, guys. So, in the previous lesson, I showed you how to hook up your ultrasonic sensor with a breadboard and connect bunch of wires and start reading the sensor input. Of course, there were some loose connections with the resistors and kind of thing. There are advantages of using the breadboard and doing prototyping and stuff like that. Like, for example, you have multiple pins, connect multiple circuits and kind of thing. You get to learn hands-on, but it gets really tricky. Sometimes the wires are disconnected. Sometimes rest of the components like resistors, capacitors, transistors and stuff like that tend to be a little loose, and the current supply within each of those pins kind of it's intermittent, right? So you got to shake properly and check what is not working, what is working and stuff like that, and you got to use multimeters and stuff like that. So it gets really cumbersome. But for the real makers who want to build solution and prototyping pretty fast, right, the best suggestion is to go for the sensor expansion board. So the sensor expansion board is something like this, right, which is pretty easy, and it just got 40 pins at the back side. You can directly plug on your Raspberry Pi, and this has got multiple ports to just hook up your sensors, any kind of sensors, right? Just plug it, hook it up, write your code, make it work. Boom, it goes live. So your prototyping is ready, quick, and you can productize your solutions, your ideas. So that's the goal behind having this kind of sensor hats and sensor boards, sensor expansion boards, right? So in this lesson, basically, we will learn about different kind of sockets within that sensor board. So in one of the previous lesson, I showed you the pin layout, right? All the 40 pins, like which are the GPIO pins, how to count the pin number 1 to 40 and kind of thing. That becomes really tricky when you start using your breadboard. However, using a sensor expansion board has a lot of advantages. For example, this particular board will provide any kind of digital, analog, I2C, PWM and UART port to meet all your needs, right? And with the help of the microcontroller unit, like a 12-bit 8-channel analog to digital converter is very well available within your Raspberry Pi. So this particular board supports both Raspberry Pi 3, 3B, B0 and Pi 4 as well. So which has got a built-in microcontroller unit. So for example, if you see the board, there is also a chip backside, right? So which has got an inbuilt microcontroller which communicates with your single board computer, that is Raspberry Pi. And this is a 12-bit analog to digital converter. And this has got multiple types of the ports, which is called a grow port. So if you look at the image carefully on the left hand side and compare that with your with the GPIO pins of Raspberry Pi, so basically look at the PWM, pulse width modulation. This particular sensor hat from Grow, the PWM port connects to the GPIO and the BCM, which is pin number 12, that is PWM 0, and GPIO BCM, which is the pin number 13, which is PWM 1. Actually, if you look at the map on the right side and compare that with the left side, that is how it has been mapped within the circuit. The circuits are inbuilt inside this. So we don't need any kind of breadboarding or wires and kind of thing. Now, this is the hardware PWM pin of the Raspberry Pi. In addition, you can use all the GPIO pin as the soft PWM pin. So it's pretty, interesting and sleeky. Now let's look at the UART. The UART port connects to GPIO 14, which is the TX pin, and GPIO 15, which is UART 0 RX pin, that is the transmission and receiving. When we start using wireless devices like Bluetooth and any other joysticks and kind of thing, this you are going to activate. The UART is commonly used on the Pi as a convenient way to control it over the GPIO. Any GPIO pins, you can change the pin numbers as you wish. We can write it in the program and load it. Let's look at the digital pin, right? There are 6 different digital sockets, right? So we don't have to really, search for the digital pins on out of that 40 pins and keep plugging the wires into your breadboard. It's a simple socket in this board, and normally the yellow wire which connect to the top pin of 4 pins are the digital pin. So basically these 6 sockets are mapped to D5, D16, D18, D22, D24 and D26 of your Raspberry Pi 40 pins. And we do have the analog port, which is that there is no ADC in Raspberry Pi, so it cannot work with analog sensors directly. Now with the help of the built-in microcontroller unit, which is STM32, this particular expansion board work as an external 12-bit analog to digital converter, which is pretty interesting, isn't it? So this means you can use analog sensors with your Raspberry Pi. So it's very easy. However, with the breadboard, it's gonna be very tough and break it and stuff like that. It's kind of unimaginable. With this particular board, you can use any kind of analog sensor, not just the digital sensors. Okay, now I2C pin. So there are I2C and SWD as well. So there are 3 I2C port available in this particular expansion board. They all connect to I2C pins of the Raspberry Pi directly. You can consider this part as an I2C hub. I would call it as an I2C hub. Most of the modules have I2C interface. So you may find these 3 port extremely useful for quick prototyping. So that's a pretty high level information. I thought it should be important for you. Now let's quickly go ahead and plug in. So I will show you how to plug in your board, the expansion board, to Raspberry Pi. So these are the pins behind, right? You can see it here. Now take out your Raspberry Pi, and this particular portion, the curvy portion, has to be towards backside, facing backside. Can you see? So that the camera slit comes out. If you are using this port for your camera, then you'll have to pull the wire like this. It becomes cumbersome. So I suggest used this port, the first port. All right, and then fix this on top. So you have to slide, and most important, guys, I suggest go ahead and procure these 2 spacer, a brass or a plastic spacer, so that you get a proper support when you fix this on the top. So I'm going to show you right now. So I fixed a brass spacer here with 2 screws at the bottom. Can you see? There are 2 screws at the bottom. So it's pretty simple. You can just mount it on both the sides and take this board. You have to plug it like this. You have to just push it soft till the edge. There you go. Now this is perfectly fitting. You should not see any gap. And then take the screw. I am going to put the screws here and another screw. I am using a hex screw, so it's pretty it looks neat, and I am going to use this kind of hex screwdriver to tighten it up. Do not over tighten it, just probably hand tight is more than enough, because we might want to remove this and fix some other hat in the future lessons. All right, take a look at it, guys, how sleek and fantastic it looks, right? So we won't be requiring any kind of breadboard at all. So you have access to all the HDMI port, the power port, and then the audio jacks, and then the 4 USB port and Ethernet, and all your sensors on the top. The best part of this board is on top of the sensor expansion, we still have all the 40 GPIO pins. Can you see it here on the top? So we can still access these pins. We can still continue to use breadboard. So that's not an issue at all. So cool. So we are set with this expansion board. Now from next lessons, I'm going to show you how to write your basic MicroPython program and activate these ports, the sensor ports and connect to some sensors. In fact, I would suggest go ahead and buy a bunch of sensors as well, which comes with 3 wires. Let me show you an example. So say for example, this is a gas sensor, right? So this comes with this particular wire, the 3 wire pin. Instead of breadboarding, we just get the socket directly and plug it, and it goes into the sensor expansion board. And we do have, say, ultrasonic sensor with the same kind of expansion wires and the socket. So these kind of sensors are available, open source in the market. You can go ahead and buy from Amazon or anywhere else online. It's available. So guys, keep these things ready. It's up to your wish. If you want to continue to play around with breadboard, that's fine. You can use the same circuit and the same codes, which I'm going to talk about in the upcoming lessons. If you want to prototype very quickly, if you want to productize your ideas into a real-time, real working product, then go ahead with this sensor expansion board. It's very, very useful, trust me. All right, I will see you soon in the next lesson. Goodbye.